Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗟𝗟𝗟𝗪 and today we're playing Unsubscriptions are free from PicoCTF, another binary exploitation challenge, and finally a heap challenge. So let's go, we download the files and we have val and val and c, solver is just my template. So let's review the source code right here. We see that we have a struct cmd and then it creates a cmd object user. After that we have a function 𝗪𝗪𝗟𝗟𝗪𝗪 and this actually opens the flag and prints it. That's really nice. This is our goal. And after that we have the getLine function, which is pretty much unnecessary right now. And then we have doProcess, which takes as input a cmd object. So this will actually execute code. And then we have another useless function s, which prints the 𝗪𝗪𝗟𝗟𝗪𝗪 address. And I say this is useless because if we go here, 𝗪𝗪𝗟𝗟𝗟, we see that pi is disabled, so we already know the address of 𝗪𝗪𝗟𝗟𝗪𝗪, so we'll never call that. And then p, right, m, account created, and leave a message. Here is one of the two important parts of the binary, because we see that it allocates 8, which is the smallest size it can possibly allocate, and reads up to 8 bytes into this. And then the other most important part is void I, which actually says, are you living? Yes, no. If yes, then it frees the user object. And the good thing here is that it does not nullify what it frees, so we can abuse a use after free technique. And here we can also see the rest of the options we have. We have them also here in process input. And last we have main, print menu, process input, and doProcess. Okay, so let's start by playing around with the binary. First of all, let's set the breakpoint at main and then at doProcess, and let's run, continue. First of all, I don't know, let's make an account, probably. Enter your username, 𝗪𝗪𝗟𝗟𝗟𝗪, and okay, let's take a look at the heap. We see up here that our 𝗪𝗪𝗟𝗟𝗟𝗪 username is located at this. And then let's try leave a message, so l subscribe. Okay, the input was bigger than 8 bytes, but never mind. So if we go ni, next instruction here, so we see that it actually takes this address right here. I'm gonna keep it as comment so we see it, this address, and it moves its content to EAX and then it calls it. So we see here it tries to call EAX, which contains this address. Where is this address located actually? We go here again, viz, and as we saw, here is 𝗪𝗪𝗟𝗟𝗟𝗪, and above that we have 84C1A0, which is this address. So it actually tried to call this one here. We see that the subscribe is right here at the bottom, nowhere to be seen above here. Let's try and delete our object with I and continue. Yes. So we take a look at the heap again, and right now we see 𝗙𝗪𝗟𝗪𝗪𝗪 and it points right here at our address. So if we allocate a small chunk like lower than 0x10, it will, instead of creating a new chunk, it will use this because the 𝗙𝗪𝗟𝗪𝗪 contains this right now. And how can we do that? If you remember here, we have a mallocate. So this will allocate space for an 8-byte buffer, and this will be right here. So let's check it. If we continue and let's say leave, and right now I'm gonna do like ABCD and viz, we actually see that we overrode this with ABCD, and the program will eventually crash at ABCD. So this was the bug, a classic use after free. And how we're gonna exploit it? We simply are gonna make an account, then we are gonna free it, and after that leave a message, so it will use 𝗙𝗪𝗟𝗪𝗪𝗪 and overwrite the address that it's gonna execute with the address of 𝗪𝗪𝗪𝗟𝗪𝗪𝗪. And let's start by crafting our payload. So create account, r.sendLine after r.sendLine, and we have m and then r.sendLine 𝗪𝗪𝗟𝗟𝗪𝗪, and then free r.sendLine, and we have here I and then r.sendLine yes, and then abuse use after free. So r.sendLine, and here we're gonna have L, and r.sendLine win, which is the address of 𝗙𝗓𝗟𝗪 blah blah 𝗪𝗪𝗥𝗘, and this will hopefully give us the flag remotely. So let's try and test it. Python solver. Okay, this didn't work. Let's see what is wrong. I don't know why this didn't work. Maybe the remote instance has pi and we don't know that. So let's try and click address r.sendLine s 𝗪𝗥𝗘 leak, and then the leak is gonna be r.regFline and then strip, and we need to convert that from base 16 to integer like this, and p32 win leak. I don't know if this is the case. Okay, so now we got the flag. I don't know why we actually had to do that, but never mind. So yeah, that was the challenge, guys. It was simply use after free. If you found the video helpful, leave a like and subscribe to the channel to support me, and see you in the next one. Bye.